are going to study equation of a circle in parametric form. So, what do we mean by a parametric form? So, let us start with the simplest form of a circle when we have the center of the circle at the origin, and let us assume that we have the radius of the circle equal to a. So, let us first try to visualize these are our x axis and y axis. Now, consider we have a circle having center at the origin and radius equal to a. Now, in order to write the equation of the circle in parametric form, what we do is we introduce a parameter which is angle in this case. So, consider here we have a point P which has coordinates x, y. Now, let us say that the angle between the x axis and OP is equal to theta. So, the next step here is we drop a perpendicular from P on x axis and from P on y axis. So, let us say these points are M and N respectively. So, from simple geometry we can find that OM is nothing but A cos theta. Let us call this our equation number 1, and PM, which is equal to ON, is equal to A sin theta. This is our equation 2. Now, if x and y represent any common point or any general point on this circle, we can easily equate x and A cos theta and y and A sin theta. So, this is the parametric form of a circle. So, the question is, why do we call it a parametric form? Because we call this equation a parametric form because here we have introduced a parameter theta. As theta changes, we get all the points along the circle. For instance, consider cos theta equal to 1 by root 2, which means let us take theta equal to 45 degree, which means we will have a point. So, if theta is equal to 45 degree, x will be equal to a upon root 2 and y will be equal to a upon root 2. If theta is, let us say, 90 degree, then x will be equal to 0 and y will be equal to a. If, let us say, theta is equal to 135 degree, then x will be minus a upon root 2 and y will be a upon root 2. So on and so forth, we can plot different points, and let us say let us take an angle theta equal to 0 degree in the last. So here we will have x equal to a and y will be equal to 0. So if you try to plot these points on this circle, so the first point will be somewhere like this. Second point will be a comma 0, which will lie, 0 comma a, which will lie on the y axis. Next point will lie somewhere here, which will have coordinates minus a upon root 2 comma a upon root 2. Next we have this point, which will be minus a comma 0, and so on. We will get different points. We will get this point, this point, this point and this point. So you see, as we are changing the value of angle theta, we are getting different points and all of them are lying on a circle. And if we try to eliminate theta from these two, let us see what happens. We know that cos square theta plus sin square theta is equal to 1. So let us square these two equations and add them. So we have x square plus y square equal to a square cos square theta plus a square sin square theta. A square we can take common, and what will be left is a square into sin square theta plus cos square theta, which is nothing but 1. So what we have is the equation x square plus y square equal to a square. And now you are very well aware of this form of a circle. It is a circle which has center at origin and has radius equal to a, which is what we started with as a from the diagram. So this clearly illustrates that a cos theta and a sin theta can be considered as a coordinate of any point lying on a circle having center at origin and having radius a. Now what happens if the center is not at, let's say, origin, but at another point? For example, let us say it is at a point h comma k. So let us try to understand that another situation. So here is our coordinate axis. And imagine our circle is somewhere here. H comma k being the center of the circle, and radius is equal to a. So the first step here is, let us try to drop a perpendicular from the center on the two coordinate axes, and let us take any general point given by p x comma y on this circle. We join the point P and the center. Let us call the center as C. We also drop a perpendicular from P on x axis and on y axis. Let us extend this to join. Now we'll name these points of intersection. Let us call this M, let us call this N, let us call this Q, and this is R, and this is point T. So now we want to find the parametric equation for this circle, which has center at h comma k and the radius is equal to a. Now if you know, if you have studied before the general form of a circle, you can easily write the equation of a circle will be nothing but x minus h whole square plus y minus k whole square equal to a square in this case. So what do we do now? How do we write the parametric form in this case? It is again very simple. Now if we want to write x, we can write x as a sum of OM plus MN. And if we consider this angle as theta, OM is h and MN is the projection of CP on the x-axis, which will be a cos theta, where a is the radius of the circle. Similarly, if we want to write y, we can write y as a sum of PT plus Tn. Pt is a sin theta and Tn is nothing but k. So here let me number these equations. Let us say this is our equation 3 and this is our equation number 4. If we simply rearrange, what we can write is, we can write x minus h is equal to a cos theta, which we will square, and similarly from equation number 4 we will take k to the left hand side, we get y minus k, and we'll square on both sides. So what will be left is a square cos square theta plus a square sin square theta on the right hand side. If we simplify this, we have the equation of the circle, which is written up on the screen, which is from where we started. Now again here, as the value of theta changes, you will get all the points which are lying around the circle. So this equation number 3 and 4, is the parametric form of a circle having center at h comma k and having radius equal to a. So let us try and solve a question here so that you have a better understanding of how do we use parametric form in our equations and in trying to solve problems. So consider we have a circle which is given by x square plus y square equal to 4, and it is said that there is another circle which is lying inside this circle and it is touching this particular circle, and it is also passing through the points 0, 0 and 1, 0. So the question is, what is the coordinate of the point of contact? So to help you understand and imagine what is going on and what the examiner is trying to ask, let us try to visualize this. Now, the first thing we get from this equation is this circle has a center at 0, 0 and it has radius equal to 2. So imagine this is a point 2, 0. This is a point minus 2, 0. This is a point 0, 2, and here is a point minus 2, 0. We can extend these two axes to have a better view. So this is, so let us draw this circle. Now point 0, 0 is the origin, 1, 0 is this point. Now the circle which we are talking about, the smaller circle which is inside this circle, x square plus y square equal to 4, is passing through these points and it is also touching this circle internally. So let us try to draw this circle. So the circle is going to be somewhat like this, and the question here is we have to find this point P, the coordinates of point P. So how do we do it? Now clearly, since P is the point of contact, if we join the center of this bigger circle and the point P, we can very well say that the center of the smaller circle will lie on this particular line. What next? The next thing is, if this line, which is let us say OP, is the diameter, then it is going to subtend an angle of 90 degree on the circumference, and the point which we have taken here on the x-axis will be the point on the circumference. Now this makes our life fairly very easy to solve. Now since the radius of the circle x square plus y square is equal to 2, we can safely assume that the point P can be taken as 2 cos theta, 2 sin theta. Now from the diagram, if we call this point M, if PM is perpendicular to x-axis, clearly 2 cos theta should be equal to 1, which implies cos theta is equal to half, from where we get theta can either be 60 degree or it can be minus 60 degree, which gives us sin theta is equal to plus or minus root 3 by 2, and therefore the point P will be nothing but 1 comma plus and minus root 3 upon 2 into 2, which is equal to 1 comma plus and minus root 3. So the knowledge of parametric form helped us to get this point immediately, and by just simple geometry we could straight away find the value of theta and hence the coordinate of the point P. So this is how different forms of circles is important, and it is very helpful in some cases to solve the problem in a much easier way with much number of steps less compared to the other forms. You can also solve this question by other methods, but it might take more number of steps than what we have done here. So this is all for parametric form. Let us move ahead and study circles in detail and understand the thrill and the interesting part of circle and what all things we are going to explore next.